Good morning. This is Rohini Bawa from Chandigarh Polytechnic College, and I'm working here as an assistant professor in Electronics and Communication Engineering Department. Today, we are going to discuss about the different methods of FM generation, or we can say FM modulators. So these FM modulators will be used for generation of FM. I'm going to share a screen with you all. It will be helpful in your further studies. So let us discuss about what is a frequency modulation. We already studied in our previous topics or our lectures that what is a frequency modulation. In a frequency modulation, the instantaneous value of the information signal controls the frequency of the carrier wave. So it is illustrated in the following figure, shows on your screens that the first one is your information signal. It is in form of sine wave. Second one is our unmodulated carrier, which is having a very high frequency without any information. And third one is our carrier modulated carrier, or we can say a modulated FM wave. So starting with the modulation techniques, or we can say the generation methods of the FM. So first one method is we used most commonly used as a direct method, which contains three type of methods. Mainly we discussed two types. First one is reactance, second one is directed arrow method, third one is our voltage control oscillator, and fourth one is a stabilized reactance modulator. And second method, that is the indirect one, in which we are going to study about the Armstrong method. So let us discuss the direct method. So direct method, in this method is called direct because we are generating a wideband FM very directly. In this method, a voltage controlled oscillator is used to generate the wideband FM, and a VCU produces an output signal whose frequency is proportional to the input signal voltage. This is the similar to the definition of FM wave, and here on your screen there is a modulated block diagram. We can say of wideband FM generation will be shown. Here it is a modulating signal which is in form of a sine wave, triangle, or any, and we can use here audio and frequency signals both. Audio and radio frequency signals both. Here it is a voltage control oscillator, and it produces a wideband FM at the output. On the other hand, in the indirect method, this method is called as indirect because we are generating a wideband FM very directly. This means that first we'll generate a narrowband FM. After that, with the help of some frequency multipliers, we'll get a wideband FM wave. So in this, the block diagram shown on your screens, that is a modulating signal which gives to the narrowband FM modulator, which is multiplied by the carrier one, narrowband wave, narrowband FM wave will be generated. After that, there is a frequency multiplier which multiplies our frequency like 2x, 4x, and so and so, and a wideband FM will be produced. So in this lecture, we are going to study about the only direct methods of the FM generation. So let us start with the reactance modulator method. In this method, the reactance modulator or transistor or FET is operated as a variable reactance. That is, inductance or the capacitive methods are used. If inductance and capacitance of a tuned circuit of an oscillator is changed in proportion with the amplitude of the modulating signal, then the FM can be obtained across the tuned circuits, which is shown below on your screens. So, basic reactance method generally consists of biased BJT and a FET, which exhibits a variable reactance with the change in modulating signal. The basic structure of the reactance modulator using a FET which behaves a three-terminal reactance shown on your screens that is connected across a tag circuit of the oscillator to be frequency modulated. The value of this reactance is proportional to the transconductance of the circuit, which can be made gate as dependable. Apart from which, if we do any of the amplifying device such as a transistor or a vacuum tube can be employed for the purpose. The circuit can be made inductive or capacitive by charging the components as per our desired. The working of the FET reactance modulator can be well understood, in which the voltage V is applied at the terminal A and minus A or A dash we can say, between which the impedance Z is to be measured. In order to determine the Z, a voltage V is applied between which the impedance to be measured and a resulting current is I will be calculated. The applied voltage is then divided by the current, giving the impedance seen when looking into the terminals. In order for this impedance to be pure reactance, so two requirements must be fulfilled. So the two requirements are, the first one is the bias network current or gate, that is IB, which must be negligible as compared to the drain current ID. And second one is the drain to the gate impedance, that is XC, must be greater than the gate to the source impedance R. So when the equivalent of, we can say the C equivalent will be equal to the R transconductance and RC both. For the expression, that is C equivalent will be equal to RC and the GM, that is your transconductance. The equivalent capacitance of the circuit depends upon the transconductance of the device and can be varied, which can be varied. By varying the values of R and C, the capacitance can be adjusted to the desired value, and the drain current, or we can say the drain to gate impedance, to be very very large as compared to the gate to source impedance for the circuit to be purely reactive. So the Z would be a resistive component in it. So in brief, we can say the modulating signal is applied to the gate of the FET, thus varying the conductance with the modulating signal. This variation in turns changes the equivalent capacitance, that is a C equivalent, which causes the frequency of oscillator to be changed. Thereafter, any change in the amplitude modulation is referred as a change in frequency of the signal. Now, there are some applications of the reference modulator which can be used for generation of FM modulation. Advantages will be they do not have any good frequency stability, but if it is to be used for the broadcasting applications, then it must have a very high frequency stability. It can be achieved through the frequency stabilized reactance modulator. I hope this is clear to you all. Now let us start with the Victor diode modulator. A Victor diode is a semiconductor diode whose junction capacitance varies linearly with the voltage applied across it. And the Victor diode must be in the reverse biases. And Victor diode method, the FM generation makes the use of feature of Victor diode, and its junction capacitance varies linearly with the applied voltage when diode is reversed bias. The applied voltage in this comprises of the modulating signal and some DC voltage source. The diode capacitance forms a part of tuning capacitor, which determines the frequency of oscillations. The capacitance, and here hence the frequency changes with the changes the modulating signal. When the modulating signal changes, the capacitance will also change. And there is a RFC coil, that is a radio frequency choke, which has been used to provide necessary isolation between the RF and EF. Here a word, that is RFC, I'm repeating again. The RFC stands for radio frequency choke, which can comes in your fill-ups of your 1 mark questions, and the use that it has been used to provide necessary isolation between RF and AF circuits. The capacitor CB that blocks the voltage signal to interfere with the basic or biasing of the next circuit. Interference of the biasing circuits will be blocked by the capacitor CB, and the internal capacitor, that is CD, of the Victor diode. It comes in parallel with the resonant circuit LC, and therefore the total capacitance will be, there will be a C plus CD, we can say, where C naught or C0, here mentioned on your screen, is a fixed diode capacitor and delta C in the range capacitance will be changed the modulating signal. So this is all about the directed out modulator. And in brief, we can say a directed out can be summarized as as the modulating signal is applied to the varictor diode through the RFC coil, and the coil is back biased to provide the junction capacitance effect. And since this bias is varied by the modulation voltage in series with it, the junction capacitance also varies, causing the oscillator frequency to change accordingly. Now, starting with some applications and functions of this. So, the advantages that it has a low noise, small size, and that's why it's having a lightweight, reliability and economical, that is low in cost, and some disadvantages. It is specially designed only to the work in the reverse bias mode. Thus, it possesses the least significance when operated in the forward bias. And there are some applications. It is one of the simplest reactance modulator circuit which is used in our daily life. It is also used for reducing the frequency modulation, and the circuit together with the reactance modulator provides the automatic frequency correction. This is the main point which we have to be in mind, that the varictor diode circuit together with the reactance modulator, when both the circuit combines with each other, it provides the automatic frequency correction of FM transmitter or FM transmission, and they are widely used for the remote tuning. Apart from the advantages and disadvantages, that it is a two-terminal device by circuit and has a limited applications, and it can be widely used. I hope this is easy to learn, and let us start with the voltage controlled oscillator. So voltage control oscillator is used to generate the direct FM. In this type of modulation or modulator, the frequency of the carrier is varied very directly by the instantaneous voltage of the modulating signal. That is, the instantaneous frequency of the output signal is directly proportional to the voltage of input modulating signal, and direct FM modulation is obtained by directly giving the modulating signal as an input the VCO. That is for the generation of, we can say, by following the followed by series, there would be some frequency multipliers and mixtures, which is used for the configuration of VCOs. So, such an oscillator provides a very good oscillator stability, constantly proportional between output frequency changes and input voltage change and it provides a necessary modulator bandwidth to achieve a wide band FM. So this method faces some problem that the carrier frequency is not obtained from the high stable oscillator. Therefore, it becomes necessary to provide some auxiliary means by which a very stable frequency generated by a crystal, which we can say a crystal oscillator, or some oscillators will be generated. Oscillator will be generate the oscillations, or a signal will be able to control the carrier frequency. This can be well achieved by stabilize the reactance modulator. So we will discuss this in the next picture. That is our next topic. That is our stabilized reactance modulator. And here the output of the generator is applied in the mixture together with the output of crystal controlled oscillator, and difference frequency term is obtained. The mixer output is then applied to the frequency discriminator, which is 2 pi Ka, and frequency discriminator, and after that it finally goes out to low pass filter. And here it may be known, yeah, we can say the device whose output voltage has an instantaneous amplitude proportional to the instantaneous frequency of the FM wave applied to its input. The figure shows on your screens, which contains an indicator, a product modulator, 2 pi Ka, and This is a 25 kf summer and a 90-degree phase shifter in it. So the transmitter attains the exact carrier frequency. The output of a low pass filter will be zero. The deviations, we can say the deviations of the transmitter carrier frequency from its desired value will cause the frequency discrimination filter combination of combination to develop a DC voltage whose polarity is determined by the sense of transmitter frequency that will be adrift. And after suitable amplifications, this DC voltage is applied to the voltage controlled oscillator to the of the FM transmitter in such a way so that modify the frequency of the oscillator in a direction which tends to restore the carrier frequency to be required a value that is the full working of the voltage controlled oscillator. Now starting with the stabilized reactance modulator, that is our AFC. So a frequency stabilization of a reactance modulator is required, and since this is very similar to the automatic frequency control system. In commercial transmitters, we can say for the operation of reactance modulator, the oscillator used should not be a crystal controlled due to its instability. This indicates that frequency stabilization of the reactance modulator or a modulation is a prime requirement, and since the system is identical to automatical frequency control system. And from the block diagram here shows on your screens, it is evident that the reactance modulator operates on the tank circuit of the LC oscillator, isolated by a buffer whose output goes through an amplitude limiter to the power amplifier. A part of the output from the limiter taken and is fed to the mixer along with the frequency of carrier oscillator. The two frequencies is the mixture stage gives out the resulting difference signal, which has the frequency usually about 5% of the master oscillator, we can say. And this difference frequency is first amplified and then fed to the phase discriminator, and the output of discriminator and the output of the phase discriminator is connected to the reference modulator, and it provides a DC voltage to correct automatically and drift in the average frequency of the master oscillator. Now, starting with the working of reactance modulator, so the diode load of the discriminator has a large time constant. Therefore, it will only react to very slow changes in the incoming frequency due to the frequency modulation, and therefore the discriminator in the circuit must be connected with the to give a positive output. That is what the use of discriminator is here. Output if the input frequency is higher than the discriminator frequency, and a negative output in case of this will be lower. So if we consider a case that the frequency of a master oscillator dips high, this higher frequency along with the stable frequency of the crystal oscillator is fed to the mixture. And the output of mixture will be definitely be a very higher frequency, which will fit to the phase discriminator. This is all about the stabilized reactance modulator, and starting with the advantages of the direct method, or we can say firstly, stabilized reactance modulator. It is comparatively high stability is achieved in this one. No modulation is required to fit the reactance modulator, and a high-class stable discriminator gives its best results. After that, there are some advantages of a direct method. First one is its simplicity of the modulator circuit. It's having a low cost, so less in weight, and the disadvantages that it's not stable enough. It's a function of various parameters such as temperature, device aging, etc. So this is all about today's lecture. If you have any queries, then you can ask me.